Hello, I'm Mr. Muskeluk, your AP Chemistry teacher at ChemAdvantage.
This is a nice problem that will let you show off your skills and knowledge of moles and chemistry. Here's the question. In an experiment, a sample of unknown alkaline earth chloride compound, XCl2, so we've got an ionic compound, was found to contain 74.5% chlorine by weight. In this problem, I've set things up so that ultimately you're going to the actual formula of this compound, but I set it up so that you could go step by step through it. First of all, we want to find out the moles present of chlorine in 100 grams of XCl2. We've got, of course, 74.5% chlorine, and we've got 100 grams of it. So as with any mole problem, if you know the element that's involved, in this case Cl, and you know you've got 100 grams, then you should be able to find the Cl present. So let's just take our 74.5 grams of Cl, because we know it's 74.5% chlorine. And of course, you know how to change grams into moles. If you're using dimensional analysis, you would end up using the molar mass of chlorine. If you didn't remember the molar mass of chlorine, scroll up on your WebAssign and go directly to our classroom link, which is right here. And once you're at the classroom link, where you have all the information on how to find out about moles and grams and what your assignments are for that specific week and that assignment, you can go to resources, and immediately you've got your periodic table there. If you want the version that's on the equation sheets, you can hit the PDF and print it, but we don't need to here. Here's chlorine, 35.45. Chlorine is used a lot in AP. It might be worth remembering that. We'll have some flashcards when we review for the AP exam. And there we have it, our atomic mass of the average chlorine atom. So let's go back to our problem. Here it is, 35.45 grams, and we've got a calculation to do. Of course, I've set this up to show dimensional analysis, where we take our atomic mass, and I flipped it over to 1 mole is 35.45 grams. The grams cancel and you get the moles. But by now you should know that changing grams into moles involves dividing. Moles are always smaller than grams. So let's pull up our calculator and do that division. 74.5 divided by our 35.45. Double check that. That's the correct division. We'll enter, and there we get our moles. Now, don't be blindly using a calculator. Think about it a bit. You say, okay, I've got about 70 divided by 30. It's going to be in the area of 2, and there we are. We have that actual value. And of course, never write out this entire value. If you're going to be showing somebody your work, show it to the approximate number of sig figs. And in this case, it's the 2.10 moles of chlorine. We've got a pretty good amount of chlorine, 2 moles, and that will be the answer here, of course, in this question. But this is just the first start, because we want to find out about X. Now, if you know the moles of XCl2, this is your next mole skill. You know that formulas are about moles. They're not about grams. If you have 74.5 grams of chlorine, you don't have 32.45 grams of X. You know that you have half as many moles, not half as many grams. So the determination of X is merely taking the moles that you calculated already and realizing that there'll be half as many of X. It is X1 Cl2. If you want to use dimensional analysis again, say, okay, I've got 2.1 moles of chlorine. I'm going to find my moles of X because I know there's 1 X for every 2 Cls. And again, with our calculator, we've left that last answer in. Don't clear your calculator. It's got important information. All you have to do is say divided by 2, and that will give you your moles of X, 1.05. And again, you'd show your work if this was an FRQ. Now let me pull up my calculator, and there indeed it's 1.05. And again, 3 sig figs on this is appropriate because we have 74.5, and that's usually all you end up needing on an FRQ. Now comes really the tough part. In fact, if this was an FRQ, they would have just asked you, what is the molar mass of X given this information? Well, again, remember, if you've got some grams and you've got a element, you can change the moles. That's usually the first step of almost any chemistry problem where you've got masses. You've got to go into the chemist's way of thinking of how much is really there. We've got 2 Cl's, moles, and 1 mole of X. And that's a reasonable answer. But what about this question? What's the atomic mass, or atomic molar mass, or atomic weight of X? Well, the unit for atomic mass is grams per mole. Well, you've got the moles. The question is, what are the grams? Well, that information is really given here. Now, before I get any further, I know this moles is going to be important in my calculation, so I'm going to store that immediately as X. Here we've got our default X there, because I know I'm going to be using that later. I'm going to need the moles of X to get grams per mole. So I'll just enter that to make sure that X is my moles of X. Well, what's the grams of X? Well, if you've got 74.5% chlorine by weight, if you take 74.5 and subtract that from that 100, you have your mass, 25.5 grams. Well, you've got 25.5 grams of X. That's that weight. You've got the moles of it. So all you have to do is take grams divided by moles. And we know the moles. That was our X. Enter. We've got a mass of 24.3. Here's the calculation. It's 24.5 grams, which we figured out from this percentage. Notice on this problem, they didn't say 74.5% chlorine and 25.5 grams of X. They expected you to figure that out. That's where you have to really think when you're doing an AP exam. If you have a molar mass or atomic weight of an element, you can figure out what it is. So let me get back to that periodic table and look up and see what has a mass of 24.3, and here it is. Magnesium, which is an alkaline earth. That makes sense. 24.3. Beautiful. So the identity is magnesium. And like I say, keep thinking. Remember, you know the charge of all the alkali metals. They're a +2. And chlorine has a charge of -1 in most ionic compounds. So therefore, this makes eminent sense that you would have a magnesium with a +2 balancing 2 chlorines. So there's the answer to our problem. It makes sense. We use all our mole skills, and the numbers work out beautifully. Well, we've done the problem. Let's look at really what happens. Here's magnesium chloride. This is sort of a misleading picture because magnesium chloride is deliquescent. If you have some pure magnesium chloride, which is a white powder, it'll absorb moisture from the air and make a hydrate. In this case, you see the hydrated crystal. It soaks water right out of the air, makes these pretty clear crystals. You can use it to remove water from things. Magnesium chloride, pretty much a simple ionic compound, but one of the uses of magnesium chloride is to melt it and then run electric current through it. And when you do so, that electric current will take those magnesium ions and give them electrons and make pure magnesium. This is one of the ways that magnesium is made. And of course, if you have pure magnesium, just like they're talking in this problem, how much magnesium would you have? You also make chlorine gas, poisonous gas. The reaction that they show here in terms of a precursor magnesium metal is taking magnesium chloride and giving it a few electrons, gaining electrons, which is reduction, and then taking the chloride, having it lose the electrons, oxidize to make chlorine gas, which is collected, and again, that's sold separately. Magnesium is a useful metal. It has a very low density, it's relatively strong, and of course chlorine is involved in a lot of important reactions. So our problem, where we had 75% chlorine by weight, and then you get the magnesium, is a real problem. It's one where you make X, magnesium, and also chlorine from magnesium chloride. Okay, some calculations and some real chemistry.